Yeah, thank you. So I will be talking some of the AI and ML for railways, and one example I can give you for signaling also. And then I will talk about various platforms and work that we are doing from TCS point of view in this area, both for the railroads globally as well as some of the manufacturers that we are working with. So can you go to the next slide, please? Uh, Mr. Murli, can you go to the next slide? Yeah. So if you look at to start with the back objectives of predictive analytics in railways, if you look at the holistic view on what does rail analytics uh, offer, in like railways, is that there are multi-pronged you can take from the railways. One is basically from the asset point of view, right? So what do you want to do is basically all your assets with the technologies that are with IoT technologies, you can have basically real time asset monitoring of your assets. And reason being, you want to improve the service life of assets. And Indian Railways being a multi-vendor based environment, you have different kinds of vendors, and then you want to really have a interoperability between all of these and achieve the service life that you want all those assets, right? And then the asset infrastructure as well. Health of these assets is very critical. So you need to measure the asset performance on what are the performance metrics that you are getting, and also the overall asset to assets that you can have, and that is the area of interest from rail analytics perspective. And then from the perspective, right, again, signaling plays a very important role in network efficiency across Indian railways, right? One is basically that is being generated. How can I improve the network efficiency and move more trains, or increase the operational efficiency of whatever network capacity that I'm having today, right? And AI/ML plays a very important role here. And we do a lot of research work in the area of routing and scheduling. And basically, we have applied this to really see how what will be the dynamic characteristics of the network optimization system, right? How do you optimize the routing capabilities if you apply predetermined rules, right? And that is one of the areas specifically for AI/ML. And then the main goal of the network efficiency is to minimize the delay and disruption, right? And even if there is a delay or disruption, how do you manage those disruptions in efficient manner, right? So that is one of the areas, key areas again.
I think your voice we are not getting it.
OEM that when he has given this assessment. Techniques like driver performance again is a very big challenge here. And again, this timetable optimization is a very important area for the area of research, particularly for AI/ML. And right? And coming to the yards, I think that is a one more area. A lot of scheduling and optimization, how you're marshalling your coaches, wagons, as so that is one thing. And then one of the critical area for your customers is basically the availability and timeliness of all your operations. So how do I achieve that? How do I forecast demand in this area? And how do I give a better customer experience, right? Again, AI/ML very important role on demand forecasting, can give you insights on what will be the typical demand patterns, and what will be the customer segments using this. So that is one area. And Finally, but not the least, safety, of course, is a part of it. And how do you improve your safety and compliance metrics that you have today with the introduction of IoT and systems that you have in place? And some of this can be used in preventing and detecting some of the adverse events that you may foresee. Again, image analytics, cybersecurity also is a big challenge because of the wide area networks that you have here in the railways. What are the techniques from AI ML domain which can be applied for cyber secure networks as well as operations? So this is a railway analytics when you look at, and each one has an impact on many things. So this is one key focus area that we work from the TCS perspective. Can you go to the next slide, please? So this is a framework for the predictive maintenance solution. What we have developed is it is again a complete IoT end-to-end stack. So when I say IoT, it covers all the areas like right from sensors, assets, right, and then the data has to data acquisition nodes, gateways, and processing layers. Like once this data it is a gateway, then you have to transmit it to IoT platform, right? So this whole stack has been developed keeping in view the requirements of railways, and railways is a very domain which has its own challenges with respect to the with a lot of image processing and machine vision techniques of drones, lidars, right? Machine vision, CCTV cameras, etc. Right? And from the sensors perspective, we monitor multiple assets in of, for example, in right. My earlier speaker was telling that current voltage of machines is a very important criteria. Along with vibration, you can do a lot of things and predict those failures. And some of the rolling stock related sensors like acoustics, laser imaging cameras and high speed cameras which can take this. So all of those machine vision as well as analog sensors that can give you the health of these assets can be collected by various devices like edge nodes, which are embedded systems which can connect non-intrusively. So again, one of the critical areas we have to mind for railways is, for example, in a signaling system, we don't want to intrude in the safety mechanisms and monitor health. So whatever monitoring we have to do, it has to be non-intrusive to the extent possible, so that there is no interference with your safety logics, etc. So all the sensors that we use typically for railroad domain and railways are mostly non-intrusive in nature, which can non-intrusively measure current, voltage, and other parameters without affecting the actions that you have, right? And then one of the again this is another good area for edge analytics for railways, because railways you have find a lot of data coming out of your assets. For example, your data loggers, or if I even sensorize some of your railway assets, right? The data will be enormous in size, and it is a fit case for to apply, so that you have a at a gateway level, you ML techniques at a local level, process the data, and then some of this data can be sent to the cloud for further machine learning, etc. Because, for example, if you have vibration, high frequency vibration data, right, it is transmit such huge data in real, it will cost you a lot of bandwidth also. So it is a fit case for edge analytics, fog computing. So again, 5G is an upcoming area. So there is a lot of fog computing locally without losing any of the things that you get today from a cloud-based system. Techniques that we have worked on and are working with our customers to enhance this. And then we call something the machine first delivery platform. So this is again, we in our system, what we do is whenever something can be automated or something is very manually done, we try to automate that, and that is our principle with machine first analytics, it is building at the cloud. One is basically the data ingestion, right, and device management. Because we're talking about more than 7,000 stations, and then there will be thousands of devices. So how do you manage the software pieces that are running on these devices, and how do I apply these patches and the security incidents that may be coming from the cyber security aspects, right? How do I manage so many devices? It will not be feasible for a system to go there manually, put a USB drive, and then upload the software. So that will not going to work with the scale of Indian Railways. So we need to have a cloud-based and automated device management strategy which can manage these devices at scale. Part, right? So there is enormous data coming into the cloud, more than 7,000 plus stations that you have. So you need to have effective data ingestion techniques, and then you need to maintain it so that it analysis. Right? And then the one of the core focus areas once like apply some of these machine learning techniques, right? And there are n number of machine learning techniques for different kinds of data, right? One technique will not work for all the kinds of sensors that you will have in the Indian Railways. So you have so many techniques. The other main important point is these models take a long time to really train. And so what from TCS, what we have is we have invested in this methodology to train some of these algorithms on this data, railway data that we are working with for global customers and models available. So if you have a data scientist and a platform access to it, he can apply various some of these problems and then create a lot of insights on this data, right? And the other piece is that is a related piece to it, model management, right? Once you have so many models, you need to have a model management technique and process so that all these models are updated with the latest data or newer assets that are coming in, right? And once all of this is there, you can create workflows. For example, you have earlier speaker were right? So if you put this kind of system to predict these failures, what you can do is you can have a closed loop system where a ticket is raised and assigned to one of your engineers who could go there, do a proper action, and then update to have can perform additional on some of these things, right? If you go on to the applications, what applications, right? You can do signaling predictive, and you can do obstacle.
I think your voice we are not getting.
On this, and then there are other techniques that you can do, like bridge inspection, track inspection with machine vision techniques, right? Automated coach inspection, again machine vision critical role here. So all of these techniques, we have built a end-to-end IoT system that all of this data in a meaningful manner can give you insights. Yes, applications on it. So can you go to the next slide, please? One of the examples of signaling, I think the focus of this program is so we have just put framework on how we are monitoring the signaling assets, right? So you can see the main critical assets are all your signaling assets like signal machines, electronic interlocking, RRIs, and track circuits, right? Including axle counters. And you already have data loggers doing a lot of this data from the relay room. Of course, they don't monitor all your field assets, but all the relays in your relay room are monitored and level crossing. So how do I monitor the health of these assets and utilize your existing data loggers to do that? See, again, one of the core important aspects is when I sensorize these assets, it has to be in a non-intrusive manner so that I don't interfere with your signaling circuits that are in place today. So we do that. Communication techniques here play a major role here because you don't want to spend a lot of money monitor this device on your buying some bandwidth, etc. So we have developed a methodology on LoRa, which is a low power wide area network, right? And it is an unlicensed band in India. You can put up a private LoRa network in that station premises where you can monitor these devices in a cost-effective manner, even though the LoRa network has low data capacity. But for a typical signaling assets and the health monitoring, that should be sufficient enough for you to capture the data. And then at a local level, you will have an IoT gateway. It will be a powerful gateway which can do machine learning locally and correlate some of these aspects with the data logger is also providing. And then the backhauling will also happen on LTE or OFC, right? You already have retail networks at all stations. So it can be leveraged to send this data, some of this data back to the data center, where you can put an IO platform to build much more powerful predictive algorithms based on AI, ML. And then also, again, very important aspect is you need a closed loop system. So you need a work order system where these defects are logged, maintenance alerts, and then there is a system to take care of it, assigned to a certain engineer in that space. And there are a lot of benefits that you get. You can have a geo-tagging of all of the assets that you have here. And one of the principles that you can get a lot of is, of course, current voltage gives you a lot of data. You can put additional sensors like vibration, which can augment that data and give you the exact performance criteria for each of these assets. So this is another framework that is very powerful in nature and can avoid a lot of failures that you see in the field today. So can you go to the next slide, please? And to give you an end-to-end digital railway, right? So what does a digital railway mean? So we have contextualized all of this into an IoT railway platform customized for railway offerings, right? So you have a single platform for all assets. You don't have to do each of these. So you have a common platform where you can get data from your signaling assets, rolling stock assets, and other operational elements, right? You have data coming in from POA system, control office applications, and backend systems, right? All of this data can be fused to give you better insights. So we have a common platform where all of this data can be ingested, right? And then you can build a data lake and apply pre-trained machine learning algorithms on this data, which is quite difficult if you want to mathematically try to put a rule, which it is quite difficult and time-consuming process. The benefit you get is it will give you insights that you may not have even programmed rules in it. Like even today you have data loggers, there are predetermined rules, but the amount of insights that AI ML can give you is much beyond what can be done with predefined rules. So all of this, the data, once it is there from all of these devices, can be exploited in a much more effective manner. You can have a contextualizing your data from all your operations. You have a central repository data, right, at a zonal level or a much larger piece, right? And then you have continuous learning. All your performance criteria as well as safety incidents are analyzed, root cause, and then these things again go back to the machine learning algorithms as continuous learning, right? And then you can have a multi-prompt, right? You can have your comments from this. Once you have a system, right, you can straight away tell what is the performance of the driver driving the train. Is he involved in many of these safety compliances, whether he is driving as per the prescribed guidelines, train performance, signaling devices performance, right? All of these parameters, and of course the safety compliance, right? Once you combine this data that you have, you can derive a lot of compliance metrics from this, and operational efficiency can be driven. And the most important aspect is the component monitoring, right? So you have so many vendors and you want to measure the performance of each of these manufacturer data sheet or standards that you have, and what kind of metrics that these people are driving. All of this can be combined, and it is a cohesive solution deploying IoT and AI ML techniques at stretch, right? So this is one layer. So yeah, can you go to the next slide, please?
Already, the slide was not visible, Sandeep.
Yeah, yeah. So I'm still seeing the old screen, but yeah, now I got it. Yeah, thanks.
Yeah, okay.
And
Let me go
if
to
you
the
look
next.
at, yeah, sorry, thank you. If you look at the core techniques, what I described, right, when I say a digital railway platform, we say this is a machine first MFDM, right? So, what are the elements of all of this, right? Then, various elements like model management. So, you have so many AI models, right? So, these models have to be deployed at scale, they have to be managed, they have to be continuously upgraded. So model management of AI algorithms is a very critical area, which is a part of the core engine that we have. Various users levels in this, right? Something about the voltage, current, etc., may not be necessary at a zonal level, right? What you want is a different view for each class of user. So there are different, and you can have a lot of anomaly detection and techniques. Again, data analytics is one of the applications that I talked about. So all users may not be interested in the same kind of data. So you have different dashboards and usage metrics for each of this. And one of the core areas driving all of this is the AI, which is basically a combination of pre-trained ML algorithms like ensemble techniques, pattern mapping, fuzzy approaches, right? Various techniques. And also, since you have once you put the iOS system in place, you have a very scalable hardware, right? So you have so many gateways at the station. So AI ML techniques that can be applied at the edge level, what we call as edge analytics and fog computing, right? So you need to optimize all your CPU, GPU management of those things, deploy models there without physically being in contact, right? And all of this is again a core. And the other piece of this is the IoT piece, right? So once you call a digital railway, which is a combination of IoT, AI and ML techniques. So IoT plays a very critical role to sensorize your assets, monitor them, bring the data to a gateway level and a cloud level. So all the techniques which are specifically with computer domain and to monitor this is another core aspect of it. And also because we are
Sandeep, can you go to the
Sandeep, your voice is not coming to us.
sir? I will check up on the contact, sir.
can you hear me now?
Yeah. Yes, please go ahead.
Yeah. Sorry for the technical problem. Can you go to the next slide, please? Hello?
Next slide is already there. Make
Yeah,
it
yeah.
bit
So,
delayed
okay.
as well.
Yeah, sure. So, again, we are talking about various techniques. So, what we have done done here is the capabilities that are required for AI training and inferencing models, right? Right from your hardware, which is of CPUs, GPUs, newer elements are coming for your AI machine learning like TPUs, etc. Right? So all of this capability to deploy models suitable for these kind of hardware elements, right? And then you, from the tools perspective, you have this and a lot of monitoring tools for these assets. And for the neural network compilers, right? We use a lot of Amazon TVM and deployed our own proprietary neural network compilers, which can work on these hardware, various kinds of hardware, which are quite powerful in running machine learning algorithms, right? And then various platforms are there today. You have TensorFlow, you have various ARM neural networks, ONNX models, etc. And from Intel, we have OpenVINO. So all of these techniques, as a part of our research group, deploy and work with different kinds of hardware, because machine learning algorithms have different kinds of hardware which should be supported, right? So that is another critical element we do, and also there are various frameworks like Keras, PyTorch, and MXNet that we have, and TensorFlow is another popular platform. We have explored and deploy at scale based on the problems, and you can see a lot of algorithms that we use today. You have of it, right? So we customize a lot of this convolutional neural networks, recurring neural networks, deep learning methods which are specifically used for machine learning of machine vision type problems, right? All of this, and then the applications that we have developed predominantly in the area of data analytics, very suitable for signaling area, video for rolling stock, etc., safety and security compliance, which involves cybersecurity. And then autonomous system. Basically, what the final goal of deploying IoT and AI is, basically these systems should be self-aware of themselves, self-healing to an extent possible. So that is another area we work, and we work across this whole stack when we say AI and ML. So this is another capability that we bring. So can you go to the next slide, please? Yeah, let me know if the slide has moved. So there's a delay on my side.
Sandeep, we'll have to request you to shortly close now because we already exceeded our time now.
Sure. Yeah. So you can go to the last slide, basically, for my closing comments there. Okay. Essentially, what we are bringing to the table is basically the value that you have with this is you eliminate many of the manual inspections that you are currently doing. You will have remote monitoring of these assets, real-time control operations, and automated work orders. Right. So all of this will reliability of real assets, and you will have the capability to predict failures based on the trends and live real-time data, and also find the very frequently occurring patterns, right? If you have some of this could be caught using AI/ML, proper root analysis could be, and mitigation measures. And finally, this will result in a lot of saving, both from the from your revenue loss that happens when some of the signaling assets fail, and then your overall reliability increases, which will have a potential savings to Indian Railways. So with this, I close my presentation, and thank you for the opportunity to present.
Thank you so much, Mr. Sandeep. It was an excellent presentation, and I'm sure once we have a copy of your presentation shared, I think we'd like to move over to the next presenter who's already waiting for quite some time.
Question, sir, from one of the presenters.
Okay, you want to read the question right now, or we take it towards the end?
Sir, I will read the question, sir. The question is raised from s.TCS Sarvana Kumar. The question is for our Sandeep Patalay. Is this recommended to use unlicensed LoRa WAN network to get the data from vital equipment such as signal lamps and point machines? Sandeep, can you answer?
Yes, yeah. LoRa is the frequency that we we are using in India is between 865 to 867 megahertz, and this is an unlicensed band. So there are public networks that are coming up, and there are also private networks that you can deploy. So that is the